Welcome to This Explainer. Today, we're doing something really cool. We're zooming all the way in from the massive scale of Argentina's agricultural sector straight down into a direct head-to-head comparison of two farm machines. Why? Well, because we want to reveal what technological innovation actually looks like when you get down in the dirt. We hear the word innovation thrown around all the time, right? Usually it's about the latest apps or artificial intelligence. But today, we're diving into the absolute nuts and bolts of industrial design to see how real-world problem-solving actually transforms small and medium enterprises. Let's get into it. But first, to really understand the stakes here, we have to look at the macro level. The agro-industrial sector makes up a staggering 25% of Argentina's entire manufacturing industry. That's literally a quarter of it. So this isn't just some niche market. This is a foundational pillar of the national economy. When we talk about improving machinery in this space, we're actually talking about moving the needle for a massive chunk of the country's industrial output. And it doesn't stop there. This sector is essentially the nation's economic engine. It accounts for a whopping 40% of total exports and generates an estimated 177 billion pesos. The scale we're dealing with is just immense. Every single slight improvement in efficiency, every piece of machinery that allows a farmer to harvest a little bit faster with a little less waste, that cascades upward into billions of pesos in economic impact. But here is probably the most critical number, 600,000. That's how many jobs this sector supports. So empowering small and medium enterprises in this space to innovate is absolutely critical for national growth. We aren't just talking about faceless corporations here. These are regional, very often family-owned manufacturing businesses. Finding ways to help these specific companies incorporate technology and add value to their products is the ultimate goal of national science and technology policies. Now let's take a second to redefine a massive buzzword, innovation. According to the Oslo Manual, which is basically the global gold standard for this stuff from the OECD, innovation isn't just about inventing a microchip from scratch in a lab. It's simply the successful implementation of improved methods that solve practical commercial problems. And that is a crucial distinction. You don't need a massive research facility to innovate. If a company introduces a change in a product structure that makes it better suited to its market, boom, that is technological innovation. It's all about bringing an idea successfully into commercial reality. So what does this actually look like in practice? Well, true product innovation is a total team sport. It's a multidisciplinary process. Sure, it begins with precise engineering, mapping out the exact mechanics and detailed schematics. But an engineer working totally in isolation just isn't enough. Those technical specifications have to seamlessly align with what the market actually needs, and frankly, what industrial design can realistically pull off on the factory floor. It leans heavily, and I mean heavily, on industrial design. Very often, true innovation in manufacturing comes down to something as seemingly simple as substituting a material to make a part a bit lighter, or creating a specialized mold, a matrix, that allows a company to mass produce a complex shape really efficiently. This uniquely combines everyday materials to add value, and it even builds a technical barrier against competitors. It's a real game changer. And of course, you absolutely need a unified team to pull the whole shebang together. You've got to align those technical features with actual marketing insights, because at the end of the day, the final product has to survive both the rugged farm field and the highly competitive market. The design has to be manufacturable, it has to be affordable for the target demographic, and it literally has to work in the dirt. This requires constant, ongoing communication between the people designing the product and the people who truly understand the customer. Okay, so how do we actually measure all of this without just guessing? Well, researchers built a really clever, targeted framework to objectively evaluate commercial, structural, and functional attributes. Instead of just looking at a machine and saying, yeah, this one looks better, we can actually decode its DNA. We can analyze its entire life cycle, how complicated the maintenance is, its structural components, and even its ergonomic impact on the user. And that totally sets the stage for our case study. All right, here is the main event. We are looking at a literal design duel between two small enterprise onion harvesters. We've got the Naivas and we've got the Escrago. Now, both of these are manufactured by small businesses with fewer than 40 employees, and both are designed to do the exact same basic job, uproot onions for family horticulturalists. Yet, as you'll see, they look and function entirely differently. Let's break down the structural math here, because this is where it gets super interesting. We are evaluating the dramatic structural differences between two machines that were engineered to serve the exact same demographic. This is where that multidisciplinary model we talked about really comes into play. We're focusing specifically on how these two different companies approach the math to solve their customers' problems, using data compiled from a direct head-to-head analysis. And bam, right away you see completely opposed design philosophies.
The Neva's machine, they achieved their goal using just 76 total parts to keep costs down while adding versatility. But the Escargot, they utilized 191 parts to maximize extreme specialized durability. Just let that sink in for a second. The Escargot machine has more than double the number of parts. It has 60 standard pieces compared to Neva's 21. It has 187 metallic parts compared to just 72 for Neva's. These are definitely not just aesthetic choices. These are fundamentally different approaches to manufacturing and innovation.
Let's look at Neva's first. Their big aha moment was offering multifunctionality. They figured out that smaller family farmers could save a ton of cash if one single machine could harvest both onions and garlic. By keeping the machine lightweight and austere, with far fewer parts to break down or maintain, they created an incredibly agile tool. The innovation here isn't a flashy new computer chip. It's the strategic decision to design a tool that solves two problems for a budget-conscious farmer. That means the farmer only has to make one capital investment. Pretty smart, right?
Then you have Escargot. They went the complete opposite route. They innovated through sheer, absolute reliability. They used more standard parts and depth control wheels specifically for user making a long-term investment in an intensive single-crop harvest. They looked at their target market and realized, hey, some farmers prioritize absolute consistency above all else. The heavier build, the superior finishes, and those specialized wheels that guarantee the machine works at a constant depth, that is their innovation. So it's a more restricted machine functionally, but structurally, it is built to endure heavy, intensive use over a much longer period.
So I want you to think about this for a second. What is the onion harvester in your own industry? Are you trying to win by offering a lightweight, versatile solution? Or are you aiming to be the heavy-duty, highly specialized tool? The fascinating thing is both Neva's and Escargot are completely successful. Both have found their niche. But they did it by deeply, deeply understanding their specific user and engineering their products to match. One competed on an agile structure and multi-use capability. The other competed on long-term robustness and precision.
The really big takeaway here, and this is absolutely crucial, is that a small business does not need to invent some crazy new technology to be innovative. Fusing deep market insights with highly targeted engineering choices, that is true technological innovation. Honestly, whether you are building a software app, designing a financial service, or welding a farm implement, the exact same rules apply. You take the materials and processes available to you, and you arrange them in a way that perfectly solves the constraints of your specific niche user.
Which leaves us with one final, incredibly important question to ask yourself about your own business. Are you trying to design a generic product for everyone, or are you truly innovating for someone specific? Because as we've just seen on the farm fields of Argentina, the absolute most powerful innovations happen when you stop trying to build a machine for the masses and start engineering exactly what your chosen user needs to thrive. Thanks so much for joining me on this explainer, and I'll see you next time.